Okay, so angles and angle measure, equations, and we're going to be solving for missing things. We're doing angle addition. Let me draw a picture here that I like you to have. There's a picture, I think I had it on the board at one point yesterday, but I didn't actually show you it. I kind of just flipped right through it really fast. It was this particular picture. A, B, C, D, and E. Okay, it was something like that. It was one of the 4 pictures I kind of flipped through yesterday, but I didn't spend time on this one. I went to like the really big one that had a bunch of numbers going every which way. All right, what they're going to be doing on this particular problem, they're going to give you certain sets. So they're going to say in the directions that AB and BC are opposite rays. Opposite rays. Okay. The big idea, what we're doing here, is that they're going to give you pieces. So that would be the instructions right above this picture. A, B, and B, C are opposite rays. What does it mean to be an opposite ray?
That means they're like 180.
180 across. So what you're looking at here, this is actually a straight line, and that's a straight angle, which is 180. So this whole thing, so all 3 of these angles are going to make 180. Does that make sense? You know it, just by that directions. They didn't have to say anything else. They're opposite rays, boom, you have 180 degrees if you put all 3 together. Well, what they do on, let's say this is problem number 10 in the book, I have no idea. Say it's problem number 10. Maybe in that problem number 10 in the book, they have this. Angle ABD is a 2x plus 5. DBE is a x plus 10, and EBC is 2x. The question that maybe this thing is asking for, it asks you to find x, or find one of the angles specifically. So if this is problem number 10, maybe off, they have this listed on number 10, but then they say find x and the measure of angle EBC. Maybe that's off to the side. You have a lot of work to do on this problem. You have to solve for x using an equation, solve, using your inverse operation, solve for x. Once you have x, you have to plug it back in. But if you didn't read the directions above the picture, you would never know how to set this problem up. You had to know that opposite rays meant you have 180 degrees in this picture. Most people tend to kind of assume it when they look at it, but you had to know it. So, my 3 angles, ABD. So that ABD is this angle right here. This is the 2x plus 5. That's the actual measure of it. That's the angle on the inside. DBE, that's your x plus 10. And EBC is a 2x. All we need to do is solve this thing out. So can somebody help me set up an equation that I can do here? There is an actual equation to these. What's the equation I can set up? What do you think? That one?
Would you put them all in parentheses and add them?
Okay, I agree. Add them all up. You can put them in parentheses. You're going to add these all up. X plus 10 plus 2x. Okay. And what does that equal to when you add them all up? What do you get when you add all 3 angles?
180.
180. That's your equation. You have to know that by interpreting it from the graph. That you can add. This is called angle addition. You can add multiple angles together to make a bigger result. If I put all 3 together, they do make a straight line. Does that make sense? You can add angles that are side by side like that. As long as they're side by side, you can do this. What I mean by side by side, they're literally all sharing the same vertex, and it's one after another, and they're not overlapping each other. If they were overlapping, we would have a problem. Because if one of them said ABE, that's this big angle. We have a problem then. So you'd have to be cautious of what they give you. So they give me each part. That's why I label my picture. I like to label it so I can figure out what do they give me. Are they giving me weird stuff I don't need? Are they giving me too much information? That type of thing. I can show you one of those examples in a little bit if you want to see. Okay, but does everyone understand this? Okay, let's solve it out. I'm gonna solve this really quick. Since they're all being added, it doesn't really matter, I can just add. So, I don't need the parentheses. So, 2x plus 1x plus 2x. Is that 5 x's? 5 plus 10 is 15. And I have the 180 on the other side. So I'm just adding like terms. Added digits, added x's. Subtract the 15 across. Notice, when I'm adding like terms, I'm not subtracting or anything like that. I'm just looking at what things match, because I'm on the one side of the equal sign, so I can just add them up. Then when I move it across equal sign, that's when I start subtracting and doing opposites. So if I subtract that 15 across, I get a 165, and then divide by 5. What is that? Let's see, it's a 3, it's 15, carry a 1, 33 maybe? Is it 33? Okay. I'll be calculator money. All right, but there you go. So it's 33. Now, are we done? No. You have to take that, you have to plug it back in. We found x. That was this part right here. We found it was 33. Boom, we're done. We found x. No. You have one more step. You have to plug it back in. You have to take your x, the 33, and plug it into EBC. They want to know the final angle for EBC. That's this angle right here. So what we have to do is we have to plug in the 33 into the x location on that problem, on the EBC. They tell you the angle you have to plug it in. So this is actually going to turn out to be 66 degrees. Just using 33. So now I have everything figured out. All right, questions, comments about that? Did it make sense? Okay, good. Now I didn't promise you a weird one. Oh yeah, question.
How come you unplug the X into the other two?
Into like these two? If they wanted me to, I could. They only wanted me to find one. So they might ask for a different angle. Maybe they wanted ABD. Sure, if they said ABD, plug the 33 in here. You can plug in all, we can find all three. You could do that. Just make sure you're kind of going after the one. Yeah, you could have plugged in that hole. Good question. Any other questions? That was good though. All right, let's get to the tricky one. I'm not going to actually solve this one all the way out. I just want you to see it. I'm going to do a very similar thing that I did here. Okay, same exact idea, but new problem. So maybe this is problem number 11 in the book. This is what they give you. Angle ABD is an x plus 3. ABE is a 10x minus 4. And angle EBC is 9. Now you're thinking, okay, you looked at it and you're like, word, isn't that just the same basic problem? You just switch the numbers and the variables and stuff. No. This is a brand new problem. In fact, I made this problem just to mess with you, just so you can see it. What we have here is they give you too much information you don't even need. Let me explain. It's going to be almost the same setup like we did on this problem, but if you actually look at what they gave you, things have changed. We relabel. So what I mean by that is that I need to put these things where they need to go. So ABD, that's this angle, ABD, that's the x plus 3. Okay, there's that. I like to label my picture. I always draw the pictures when I do my homework. So there's ABD. ABE, here's the problem, if you can see it. ABE is this entire angle. That's the x, or 10x minus 4. That's the big angle. And then the EBC is a 9. This is 9 degrees. All right. Why is this problem different?
The two angles overlap.
Yeah, the two angles overlap, if you can see that. I had the green one and I had that bigger one that overlapped it. there's two ways to process this problem. You could subtract the two from each other, like take the big one, subtract this off of it. That way you can figure out what the small one is. That's one way you could do it. You could actually subtract them, so you can figure out the other piece. Or,
Couldn't we just like not use a small one at all?
exactly, that's the second way, and that's the way I almost recommend it. So if you didn't get what Anderson's saying there, you don't need to use the x plus 3. Don't even use it. If you just get rid of it, now you have all three angles accounted for. You have the big angle, and you have that one, and what do they all make? 180. So you could just do this. And that's the way I would almost recommend it. So that was a good spot. You just add the big angle and the 9, and now you have 180. That covered the whole basis. You didn't need to use the x plus 3. It was just thrown in there to mess with you. And then you could add these together, so that's 10x plus 5, and you could do the whole process here. So subtract the 5, subtract the 5 across, you get 175, and divide by 10, and you get 17.5. Now, what do I have to do with that? Plug it in. And it matters which one you plug it in. So maybe the question changed. Maybe now they want you to plug it in to ABD. They want you to plug it in here to this one. That's ABD. Well, now you need the small one because the small one was ABD. So now you want to plug the 17.5 in here so that you can actually answer that question. So it'll be, what, 20.5?
Yeah.
Questions, comments about this and how I did it and why I plugged it in? It's just one of those things, you just need to see that, and that was a really good spot by that. But some people can do it differently. You might want to subtract, find the small one, or you can just take the big one and the other one. You don't need to use all three parts. Sometimes they give you stuff you don't need. There's always multiple ways to do these problems. Don't feel like you're doing it different, or wrong, I should say, since you're doing it differently than somebody next to you. Okay, we're good? Okay, last thing I want to cover today is I want to talk about some constructions. You need to take out that piece of paper we did yesterday. Yeah, that blank one that you had to put your name in. I think we did, what, 3 constructions on it? We did congruent segments, where you copied a segment. We did one where you had to cut an angle in half. That was called an angle bisector. I think that was the last one we did. And then the one in the middle was like we did a perpendicular, where we do that 90-degree angle perfectly yesterday. Today we're going to do 2 more. So you need a piece of paper out. You can put it on there. Now if you're out of space, let's say you used all of it, I'll give you a new piece of paper and you can staple it to it. So just wait 1 second. Okay, I'm going to hand these out. If you're missing lead, just let me know. I should have enough for everybody in here. Yeah. Real quick. All right, good. So let's stop the camera. Okay. All right. So let's go through this pretty quick. Make sure you have your compass, your straight edge out. Make sure they're ready to go. If you don't have lead, just let me know here in a second. We'll get you taken care of. We're going to do the next 2. Does anyone need new paper? You're out of space. Okay. You know what's going to happen? We always have a few. Okay. So if you need new paper, I have it back here in case you need some. Anyone else need it? Or you got room for doing 2 more drawings? There we go. Yeah. You do it. All right. Hey, here we go. Okay. First thing I want you to do, I would like you to draw a line segment on your paper somewhere. So this is construction number 4. So you're going to take your straight edge, draw a segment. Don't draw it too big. Just draw a segment on your paper. So this is construction number 4, the new one. Let's label it, let's call it X and Y. Now yesterday, remember, we learned how to draw, how to copy a segment somewhere else. We talked about how to draw a perpendicular 90-degree angle just using your compass. We talked about how to cut an angle in half. Those are the things we did yesterday. Today, we're going to learn how to draw a 60-degree angle without your protractor. A 60-degree angle, very weird angle. It's used a lot in pre-calc and geometry and stuff. 60 degrees, not 90, 60. Kind of in the middle spot. Okay, so how do you do it for a 60? Take your compass. What I would like you to do with your compass is measure the length of XY. Measure how long it is. Hopefully you have a little bit of room either above or below. We're only going in one direction, so if you have room below it, you're fine. If you have room above it, you're fine. Don't put it at the bottom of your paper. Hopefully you got a little bit of room. All right, so you're gonna measure XY the length. Try to get this thing correct. Remember, use the gear in the middle to open up your compass, don't pull it apart. Now that you have this measured, what I'd like you to do, put the pike on the letter X, and what I want you to do is just swing your compass up and make this big looping arc. Big looping arc. All I did was I measured X, Y, and I looped upwards. Once you have that, leave your compass alone, flip it around, go from the letter Y, and do the same thing. And they should cross either below it or above it. I don't know which direction you're going. Because some people went down, they didn't have enough room above it, so they go down and do the same thing. Did they cross at the top somewhere? No?
Yes.
How did it not touch?
Pike from Y. I did.
From the Y?
Oh, it's a
Yeah, there you go. Simple fixes. You had me worried there. I was like, how did they not cross it? Anyone else need help getting that? Okay, now that you have that, all you need to do is take your straight edge, and we're going to draw the line from X straight out to this new point out here, we'll call this Z. You're going to draw that line straight out to there. It can go from X or Y, I'm just going from X. Now, if you don't know, basically this construction we just did was very similar to that perpendicular one we did yesterday, the 90-degree angle. Because I think 90, yesterday I just said, you just had to open up past the halfway point. This one, we went all the way across. And when you went all the way across, it actually makes a 60-degree angle right here. It's kind of cool. That's 60. Now, why that's important? You're thinking, why 60? Why do we even care? 60s are used in triangles like equilateral triangles. So you can make a triangle that's perfectly symmetrical, like perfectly regular, that's what they call it. We can cut 60s in half and make 30s. We can cut 30s in half and make 15s. We can cut 15s in half and make 7.5s. Like, there's a lot of uses for getting a 60 because we can build off of it. We can use that angle. We can do stuff with this to make other drawings. Okay? So now you know how to draw a 90. Now you know how to draw a 60, and the steps are almost identical. The 90, the only difference with 90, you just had to go down below as well. So it made the two X's up and down. You drew a line. But 60 just went up. And you went the whole way across. Questions? Perfect. Let's move to the last drawing. Last drawing of the day. Last one. Absolute last drawing. Take your straight edge. So you need to have some space in your paper. If you need more paper, it's up there, it's in the back. You can go grab one if you need one. Maybe you ran out of space. What you need to do now, take your straight edge and draw an acute angle on your paper somewhere. Don't draw it super tiny. Like, what I mean by tiny, don't draw it like this. I don't want one of those. I need something that maybe has 30 or 40 or 50 degrees in it. The bigger the angle, like the actual number-wise, the easier this drawing will be, because this is the first time you're ever attempting this. So draw an acute angle. Make the rays of a decent length. So use your straight edge, draw your angle. Let's label this angle, let's call this A, B, and C. So here's my angle. A, B, C, B is the vertex. Alright, this one is by far the most difficult construction we're going to do. You do need room for this one because the drawing we're going to do will be somewhere else on your paper. So if you don't have room somewhere else in your paper, you need to go grab another piece of paper, which is fine. Alright, what we're going to learn how to do on this one, this is by far the most difficult one right as of this moment. we're gonna copy your angle, that angle, to a new location without measuring it, without using a protractor. Make a perfect copy, whatever that angle is, to new location. Somewhere else that there is room. Got it? Go to the space in your paper where you want to put your angle. I'm gonna put my angle over here. I have a lot of room over here, it's pretty. Draw the segment so it kind of looks like BC, or whatever that segment was on the bottom of yours. You want to draw a segment that kind of looks like it, and no, you don't have to measure it. Just draw your segment. This is where my angle's going to start. Now, wherever you put it, you need room above it. So if you put it at the top of your paper, you're not thinking real clearly about this. Because we're going to copy the angle right here, and I need room to draw it. So if you're putting this at the top of your paper, there's no room. I don't know what you're thinking. That does happen. Okay, we're good. Does everyone have their new line drawn? Do they have their other angle we're going to copy? We could have copied that one, but I don't want to copy 60. It's easier drawing 60 by itself than trying to copy it. Okay, everyone's got it? Pick up your compass. This is pretty straightforward. These steps are pretty quick. Hopefully you're paying attention. What I want you to do, take your compass, you can open up to a random length. I don't really care where it's at. That looks good to me. I haven't even looked at the picture yet. That looks good. All right, what we're gonna do is you're gonna put the pike on your vertex B. And all I need to do is draw an arc so it hits both walls. When you do that, it's gotta hit both walls, so if you open up your compass too far, you gotta shorten it up a little bit. It's gotta hit both walls. Don't change your compass after you do this. So once I have this arc drawn, I'm gonna leave my compass alone. So is everyone good? They have their arcs drawn. Pick up your compass, leave it alone, go over to the new drawing, and draw the same arc. Now this is the part where most people will make a mistake. They won't draw this arc long enough. If you want, draw a semicircle. Semicircle is half of the circle, if you need to. This thing needs to be long enough. Nothing's worse than somebody that draws it super short, like this, where it's like this big, where it's really tiny. Okay, you need to copy this angle. It has to look identical, so it's got to be pretty long. The other thing you got to make sure of, did it actually touch here? If it didn't, you did it wrong. It's got to touch. It's got to do that. Because on my original picture, it also did that. It also hit. It has to hit both walls. Does that make sense? Okay, does everyone have that arc drawn on both? And did it hit the walls? And did you draw it long enough? Once you have that, you're going to go to this picture, the original picture, and I need you to measure with your compass. Your compass is going to sit here, right? This is where your compass is sitting. It's a little gear. You need to measure that gap where your arc actually hit. It's kind of like what we did yesterday when we were doing that one angle bicycle, the one that we cut angles in half. We kind of did that similar situation yesterday. We kind of put the compasses here. All right, you need to measure. This is the point where you're going to be changing your compass. You have to change the compass to actually measure that. So I got to measure how big this is. So you're going to have to use that gear. You've got to make it the right size. Once you have that, once you have this perfectly measured, this takes a while. Usually you got to like get it pretty spot on. You're going to pick up the compass, go over to the new drawing, and make that final mark. It should do something like that. And again, where I'm putting it, I'm putting my compass here, like that. Kind of like what I did in the original picture. And I'm going to make that mark. Once you have it, you're done. You can draw your final line, you can copy your angle. The final line goes from here, straight out through that new spot you just made. And they should be identical angles. You can measure them. If you follow my steps, they are exactly the same angle. Some people don't believe it. It works. It works every time. You can do this for any angle. You can copy 90 degrees angles. You can copy 60s. You can copy other things. As long as you have a picture of an angle, you can copy it just using this and a straight edge. No compass needed, which is kind of cool. So if you're in architecture and you're trying to design a house where all the angles in the house are similar, maybe it's not perfectly like 90s, so there's like weird angles in the house, You can calibrate those angles to new locations using this with no protractor needed. It makes bare minimum markings. You make a couple slashes, marks, and they're really light, and you can fill them in later. Here's the test. Did they look somewhat the same? Did they look good? If it looks good, you're probably fine. If one looks way bad, you did something wrong. Maybe you didn't measure. Maybe your compass changed. Maybe you didn't measure this correctly. Or you went from the wrong point. Like you try to measure A to C, that's not what I cared about. Okay, we're good? All right, homework today. Compasses, straight edges, put them back in the baggie. I'll walk around and collect them here in a minute. Homework that we had to do yesterday, if you did not turn this in, you're already late. Now it's 15% off. Think about that. Okay, but homework that's due on Friday this week, so you got a couple days to work on it. And yes, I'll give you more time tomorrow, because today we don't have that much time at all. Because what's Friday, the 14th? I need my red. All right, so homework due on Friday this week is boom, the homework assignment on page 41 is numbers 1 through 10, 20 through 23, 30 through 35, 37 through 39. You will need a protractor. If you've already lost your protractor, you have to go buy one. You will literally not get half the problems right without a protractor. You have to measure. You have to measure angles. If the picture in the book is really tiny, you can extend the walls. I'm totally fine with you doing that. Take a light pencil, extend the walls further, use a straight edge, and then you can put your compass on, or a protractor, so you can actually measure it. You're allowed to do that. If you have your online textbook, you can just zoom in. I don't know if the online textbooks are working, so I'm not going to even tell you to sign into that. That was a disaster. All right, well there you go. It's due Friday. Okay, you got about 8 minutes. So.
Are we getting that page in?
Yes, that page, we just did the constructions. Name on it. If you have 2 separate pieces of paper, I want you to staple it together. The stapler is right here. You need to check if there's staples in it. There is, there's plenty. Staple it together, turn it in the basket, you get points for doing that. That's another time you have this.
She's still better. She started with the 14th, off for one day.
Remember, we don't erase stuff. Okay, I'm gonna walk around, I'm gonna collect. If you have not turned in your constructions, get those turned in. I need those. You need a stapler. I got a stapler right here. Some people use different pieces of paper. Remember, you need a protractor. If you've already lost it, you better go get one. You need it.
I don't want to do it.
Okay. Protectors, all.
I answer that.
Falling forms. I already gave you guys the protectors.